So we have a bunch of people online as well. I'm echoing. Oh,
Yeah.
perfect. Thanks, Haley. Well, thank you so much for being here. I am Pınar Karacamandic. I'm a professor in the finance department and also the founding director of our Business Advancement Center for Health, which we call BAC. And we are thrilled to have this seminar joined with the university's data science initiative. You know, they've been supporting us, the school, as well as our programs from the very beginning. But I think this is our very first joint event together, and I'm really hoping that we're going to have many more events together. So just quick introductions. BAC, for those of you who don't know, is a center at the Carlson School of Management, founded in 2022, to really innovate more through the business-driven innovations to reimagine health and healthcare. And a lot of the work we do is data-driven, evidence-based solutions and innovations that can create sustainable opportunities for some of the challenges that we have and opportunities we have in healthcare. And for those of you who do not know, Data Science Initiative, DSI for short, is a hub of innovation at the University of Minnesota that gathers together communication, amplification of all the data science and data-related activities of faculty and researchers and students across all the schools in University of Minnesota. And today's topic, as you will see, is LLMs as bridges connecting healthcare data, policy, and operations in the AI era. And we are so glad that, to have Yubin Park from Mimi Labs, that you can tell a little bit about Yubin when you have the opportunity. So I'm just going to go through very quick logistics. We have 90 minutes. Yubin has generously agreed and is welcoming questions coming along as he's speaking, so do not be shy. Just raise your hand, and Anna is going to bring you the microphone because we want to make sure everyone on the online audience can also hear your questions. And those of you, the virtual attendees, please use the Q&A, and I will be monitoring the Q&A, and I will basically raise my hand and asking Yubin your questions as much as I can. But if there are any questions left at the end too, you know, we will get through those questions. So the talk is going to be recorded and will be posted on the DSI's YouTube channel. Now, a few things about today's talk is I want to introduce Yubin first. So Yubin said, do a very short introduction. Just say this random guy. It's like Yubin. But it is like our introduction is actually through LinkedIn, because what I as a healthcare economist, I follow LinkedIn as a professional, platform to watch some of the ongoing happening things in healthcare. And of course, as a data person myself, all my work is empirical. I always look for healthcare data and what can we learn from it. And then I see Yubin's post pop up is like all these graphs and charts that he's posting is like, and it was one of those kinds of interactions, and I think, I can't remember, but maybe it was on risk adjustment. Like Yubin posted some interesting patterns, and I was like, oh my God, what is this? And started looking at it, and I saw that a lot of actually my colleagues, higher level executive colleagues in some of the health plans, and they were writing back to Yubin. I was like, who is he? And so we started communicating, and yeah, I was just fascinated with sort of the platform he's creating, the data that he's collecting and working on. And I said, Yubin, do you think we could partner with you for our University of Minnesota interdisciplinary health data competition that we are hosting through the Business Advancement Center for Health? And he graciously agreed. So we have our students, we launched our competition February 4. It was the kickoff. Yubin and his team has put together a fantastic data set for our students to work on. And our students have really taken these data, and they're looking at like provider level data. We put together a data set on healthcare providers, performance, quality, payments and utilization, and social and community context. So we have our finals at 4 p.m. today, 4 top teams, and we will have the finals judging. So thank you for being both, for this event as well as for all your contributions for the university's competition for the students. So Yubin is a leader at the intersection of healthcare, AI, and data analytics. And he's the founder and CEO of Mimi Labs, and you will hear from him as well as several other startups, healthcare AI startups that he exited. He has a rich background as a former chief data and analytics officer at Astrana Health, where he developed strategies that unify diverse healthcare data to improve patient outcomes. He holds a PhD in machine learning from University of Texas at Austin, and his work is basically developing AI-driven platforms focusing on risk adjustment, quality measurement, and virtual care, and has really demonstrated some important practical applications to learn solve like real-world healthcare problems. In addition to his entrepreneurial and industry work, Yubin also serves as an adjunct professor at Emory University, where he brings his academic insights into the classroom as well. Again, as a LinkedIn top voice, he regularly shares these valuable insights on the future of healthcare AI and data, and just digesting these really, really complex healthcare data sets, all publicly available, released federal data sets, but just kind of like going into them. And so thank you so much, Yubin, and the mic is yours. Thank you.
Thank you so much. In 2009, Todd Park receives one phone call from Deputy Secretary of HHS, Bill Carr. So Todd Park is a successful entrepreneur back then. He founded an EHR company called Aptina Health that was already in the public market. He's a very, very wealthy man. So he was about to retire. Bill Carr was working for President Barack Obama, and they wanted to change the government. And they reached out Todd Park to have him as a chief technology officer at HHS. Of course, he refused many times. Why would you do that, right? I already have money. I'm already successful. Why would I go there and to get blamed for, right? But in many ways, I think through many discussions with Bill Carr, Todd Park saw the opportunity to change. So he accepted the job. And many things happened back in the days. It's a long time ago. So 2009 and 2011. So it's now almost more than 10 years ago. In 2011, he had an interview, and actually he talked about this in many conferences, that he wants to make HHS like NOAA, NOAA. Have you heard about what NOAA is? NOAA is essentially, it manages a lot of data about our weather and Earth. When you look at the weather forecast, and actually before flying to the Minnesota, my wife was kind of warning me, is this enough? Aren't you prepared enough to go there? And I said, yeah, no, it looks kind of warming up. So I can go there. I was checking the AccuWeather, right? AccuWeather, the weather company, or all these news channels, they talk about the weather. Where do they get the data from? Right? Do they have satellites? Do they have all the monitors in all across the US? Nobody has them all. NOAA has it. NOAA collects all the data. They provide the data for free to these companies, right? So by providing this data to these private companies for free, it created all this value chain, right? That's kind of what he wanted to do. He eventually became the chief technology officer of the US. Actually, he went back to he ranked up. Then he did a lot of cool things, not just for the HHS, but he created a lot of different websites called the data.something.gov. So nowadays, actually, you can go to data.cms.gov, data.healthcare.gov, data.fda.gov. So all these three-letter agencies, there is this prefix, data.something.gov, where you can find a lot of data from the government. Open data can create enormous value. And a lot of these estimates, I don't know, to be honest, whether I can trust them or not. These are all guesswork. But some work says it can create 0.5% of the GDP. With or without the open data, can change that. It's quite a bit. Bringing some other data point, it's from McKinsey. So they also estimate open data has enormous value. And it's all across different sectors. And the healthcare alone, it can be $300 to $450 billion, quite a bit. The number is from quite a long time ago. This number must be in 2013, more than 10 years ago. I believe the value of the open data in healthcare may be surpassing $1 trillion. Open data is not just about the business as well. This chart, can anyone guess what this chart is about? So there is this website called the Archive. It's a lot of computer scientists, actually, they publish their preprint papers. Computer science became a little bit too much competitive. So they cannot wait the peer review completed. So they just need to publish it first because I need the fame. I did the first. So in computer science discipline, we publish papers on the archive before peer review is get completed. This is the number of papers submitted to the archive for the AI topic over time. It's going up. And this is actually estimated per monthly basis. Each month, we are getting almost 10,000 papers just for the AI. These are not random papers. Actually, to submit to archive, no random people can submit these days. You need to have a certain credentials. They do a bit of a filtering to get qualified to submit to archive. The number of papers get published just for the AI is enormous. Yep.
So is this generating new dollars, saving old dollars, improving quality, or some combination?
I think it's all.
I'll ask it again here. Is there an online audience? Is that the idea?
That's right, yeah.
Yeah, so my question is on the economic value. Is that generating new dollars, saving old dollars, or improving quality, or just what's in there?
It's based on my recollection of their report. I believe it's a mix of all of those. So the open data can be used for process improvement, but as well as value creation as well. So a lot of those are kind of mixed, and in many ways, this is a really kind of crude estimate. Even from the report, they say that it's a kind of something they cannot quite assess kind of quite accurately, but this is kind of what we view it as economic value, with or without the open data. And coming back to the progress of the AI, how did it happen? There are many different theories, but the one big theory that getting a lot of support, and I support that theory as well, is because of this person, Professor Fei-Fei Li. She's a professor at Stanford, she created a data set called the ImageNet. What she did is amazing. Almost 20 years ago, she collected a bunch of different images and she started labeling them. This is cat, this is dog, this is chair, this is person, traffic light, all those different categories of the images, and then she started labeling them. And what she did was amazing. She released the data publicly, right? So that actually cultivated the progress of the what we call now as deep learning. I studied machine learning long time ago. Not that long time ago, but I often jokingly say that I studied machine learning when machine learning was not hot. So I could get into a machine learning program because it was not hot. If I applied now, probably I get already rejected right away. But when I was studying machine learning, I was actually asking, and I was kind of having a chat with my advisor. Neural nets were disregarded very, very harsh. Neural nets, had a reputation that it doesn't go anywhere. You don't get funding. Nobody will support you. No companies are using it. It was around the early 2000s. I studied a lot of different kinds of machine learning, convex optimization, a lot of matrix theory, a lot of linear algebras, and all those things. I mean, in many ways, it's a foundation of a lot of different things. But the neural net is something I never looked into, but also nobody quite cared for, especially in the US. When Fei-Fei Li published this data, all across the world started applying these data sets to figure out how can I recognize the objects in the image. It became an ImageNet competition. When a competition is open to the worldwide, people apply all sorts of different things, right? Neural net, although it was not having a nice name in the US, it was continued to be researched in Europe and Canada. Those people published the result, and it was surpassing all the benchmark in the prior, all the developed algorithms. People saw the opportunity, and that was the inception, how the deep learning came about. So what kind of open data am I talking about? So there are a lot of different kinds of open data. Open data can come from private companies as well. It can come from government, state government, or federal government. For this talk, I'll be mostly referring to the healthcare open data. That's the industry I know a little bit better than other industry. And because healthcare is half public and half private, it's a fairly heavily regulated industry. We have a lot of data from the government. So I'll be talking about those government-provided open data today. So, long story short, has HHS became NOAA after 14 years? I think to some degree, yes. A lot of our government data sets published from that time on created different kind of industries, but in my opinion, not quite yet. The size of industry is this much, but we are only tapping this much. I think we have a lot more to go. So now I'm stuck. I'll stop here a little bit and give my story a little bit. So I'm currently a CEO at mimilabs.ai, and this talk is mostly related to what I do at mimilabs. But I'm also a CTO at a company called falconhealth.ai. It also utilizes a lot of open data, but it's focused on fraud, waste, and abuse in healthcare. Prior to that, I was Chief Data and Analytics Officer at Astrana Health. It's a NASDAQ-traded company, and I was one of the executive running a big data team. So the Astrana Health is not quite well known, but it's essentially what we call as a risk-bearing provider group. It's a combination of the payer and the providers. They are very big in Southern California. I have founded a few companies in the past. Right after my PhD, I founded a company in Austin. And the company was sold to a company called Evolent Health. It's located in Arlington, Virginia. They are also publicly traded. I was there a little bit, came out, did another startup that became acquired by Astrana Health. So my background is fairly simple. I did the 2 startups and the 2 corporate experience. And the funny thing about me is I never had a job interviews. So when people ask me, how did I start here? Why am I here in the healthcare industry? To be honest, I don't know. I just ended up here. I was also talking about the story last night when I was having a dinner with Pinar. So the Pinar was asking, how did I start my first company? I think I started my company because I had nothing to lose. I was already very poor as a graduate student. I cannot be poor anymore. And my wife was still at school. And I felt like, okay, I have nothing to lose. I don't want to go work for Silicon Valley companies. Maybe I can spend some time doing, maybe I can, spend some time to really change the world. I was a little bit ambitious without much concrete plan. So I wrote a proposal to NSF. There is a program called the SBIR. So if you're running a small business and if you're focusing on some scientific problem with the scientific approach, you can write a proposal. They provide small grant to set you up. So the funny thing is, I really didn't know where to start. All I knew about the US and the business, really nothing. I was reading a bunch of newspapers, and the one thing was clear. US healthcare seemed like having a lot of problems. And based on my research, maybe the technology in the US healthcare is perceived as very outdated. Seemed like a low-hanging fruit. I thought I could make a quick money and be comfortable. It was a big mistake. But I wrote the proposal, and the proposal got accepted. I think also NSF reviewer didn't know what they're reading either. Funny thing is, I couldn't quite continue what I promised as I wrote in the proposal. And this is actually the main piece of this talk. We feel like we know healthcare. And I read a bunch of different articles. At the time, actually, I felt like I was feeling pretty good that I knew I understood healthcare. Maybe I can do something about it. When I tried to do something, I felt huge barrier. It's not just it's not like just turf or anything. It's the barrier of my ignorance. So I realized in the end, I never worked in the healthcare industry. I'm a computer scientist. And there are a lot of computer scientists who want to work in healthcare. And even back in the days, nowadays actually even more, they made a bad mark. Healthcare people do not like computer scientists. They come in, they make a big mess, and they just leave. And I also was seeing that kind of pattern, and I realized, okay, let me be clear. Let me accept I am an outsider. let me view this industry from an outsider. How can I learn? I started collecting data. I started learning about how the industry works based on the data. And it took some time, maybe about 10 years. That's the time I spent in healthcare. But I think I've been studying quite hard. It's a little bit shy to say to my advisor, but I actually think I have studied healthcare a lot harder than my PhD subject. So I don't know if you have heard about this old story, blind man and elephant. I was kind of Googling up, and it seems the story is potentially kind of, originated from India, but it has many versions in China, Korea, and Japan. So the story goes like this. There are kind of like I don't know how many blind men, but if there are blind men are there to figure out what the elephant looks like, right? One blind man goes there and touch the leg. He describes it as, it's a big trunk. Yeah, tree trunk. Another blind man goes there and touches the nose and says, elephant is like a snake. And then another blind man goes and touch the ear. Oh, elephant must be like a fan. So everybody touches different parts, and they're imagining completely different things, right? So the funny thing about these Chinese words, I believe actually not many people understand what this means. This is actually a Chinese word for imagination. And it's a combination of the first letter is think, second letter is elephant, right? So the imagination, the word in China, actually in Korea and Japan, we use the same word. So when you're imagining something, we always think of blind man and the elephant. We are thinking based on the fact we know, but the fact is very limited. Healthcare is very complex. It's a very complex industry, and a lot of times we get exposed to a very partial, very fraction of the healthcare industry. I have worked in the healthcare insurance industry for some time, and even within the insurance, I touched a kind of subset called the value-based care industry. When you look at the healthcare, there's a pharmaceutical industry. There are all these different programs, device industry. There are public health and a bunch of different things, and we often call it as a healthcare, right? And but the funny thing is, there's a reason why we call them together, because they are all interlocked. They are all affecting each other to some degree, but they are within our limited experience. We only experience a partial, small fraction of healthcare, and knowledge doesn't see the full picture a lot of times. But it's not all that why healthcare is so complex. Healthcare is complex because it has rich history. And it's being overwritten by many, many different regulations. And when you think of these things, I don't know if you write the code. I write the code by myself every day. I write code one day and I'll fix it tomorrow. And I'll fix it tomorrow. Sometimes I forget about it. It doesn't work. I need to go back and fix it again. A lot of times, I don't exactly remember what I wrote back in the days, right? I need to think about it. Oh, what was I thinking? And then you kind of infer what you exactly have done. A lot of times it's wrong. And I append some patch. Again, it fails. And I add other things. And it becomes like a rugged cloth. It's you have a lot of different patches, and the software becomes very, very difficult to understand. To some degree, I think the current healthcare system is like that. We've been adding a lot of different patches. There are a lot of problems, but there are a lot of times we cannot quite think of, and in many ways, it's easier to fix the small problem first than the root cause problem. So we've been adding a lot of different patches. And those patches are actually, each patch is quite complicated, and they get overlaid over years. Whenever administration changes, those things get overwritten, without quite understanding how things are established back in the days. So through the process, context gets lost. Historical reasons fade away. A lot of those patches had its own reasons, but a lot of times we forget about exactly why we did that. Documentation lags. Federal government, when you look at all the data produced by the federal government, funny enough, it's still produced by a lot of IBM mainframe and COBOL language. Not quite the advanced programming language from the DCX standard. But more problem is all these code that is running in the federal government. There isn't much about documentation. A lot of institutional knowledge is with the people's brain, and they fade away. A lot of tribal knowledge. It's very difficult to learn about the exact workflow, how things are done, how actually a plan's operating, how actually each case, what should I do about it? Those things reside with the very specific group of people. And when you ask why you're doing this way, a lot of times people without those knowledge, they will tell you it's always been this way. Learning is hard. No single source of truth. When you try to learn about the healthcare, to do any business in healthcare, try some Googling. Funny enough, I think, not to offend Google, but I think Google search result is getting worse and worse. Not because of Google, but I think we are getting a lot of noisy web data. It's very difficult to find trustworthy, reliable sources. And there are a lot of also AI-generated contents are causing a lot of issues as well. And it's adding noise. And one article says one thing, the other article says different thing. All those things make me confused quite a bit. Information asymmetry is everywhere. People make money using information asymmetry. One person knows one thing, the other person doesn't. That creates opportunity in healthcare. I mean, not just in healthcare, but I have seen those cases a lot more in healthcare. Experts in one area are beginners in other areas. It's because healthcare is so fragmented and they're very complex. And the changes affect everyone's life. So it's not just easy, like scraping it and just starting over. And the story about this blurred image, I didn't intend to do this, but when I put the image, I actually didn't realize the image was like this. But you don't need to read the table too closely. But my message is simple. After all the effort to publish the data, to become like Noah for 14 years, why are we not there yet? It's because we are open. We are opening a lot of data, and we can learn about the healthcare using the data. But openness is not equal to liquidity. What that means is healthcare data is starting to pouring out, and we have access to data, but we actually don't know how to use them. The data is not liquid enough, and the data is not quite working for us because the data, I can access data, but it doesn't mean that I can use the data. open data is not free. Open doesn't mean immediately usable, right? So the things that we talked about before. So have you tried to use a payer transparency file? No. You have used that as well? Do you know about the payer machine readable file? Yeah. So a few years ago, all the healthcare insurance companies, so-called payers, they needed to provide prices for selected procedures by the Payer Transparency Act. Payers like Medica, United Health, all these companies like Humana, Aetna, they are publishing this what we call as a payer MRF, machine readable file. It's good. To some degree, yes, payers started actually publishing the data. But when you try to download it, that's the first surprise. For example, United Health, they actually have 50,000 files to download and get updated every month. Each file is multi-gigabytes. And the file is not like Excel or anything. It's called something specific JSON format. Only some computer science techies would understand. And you need a very special program to open it up. What's happening is they are publishing the data, but not many people are able to use the data. So they are processing the data is still as expensive as before. To some degree, it created some additional industry to parse the data and to sell the data. But I think that's a little bit of a different kind of value chain. I don't think actually they are adding a lot of values to the industry back. Yeah. So that's one example. But that kind of example happens a lot in healthcare. We are publishing the data. A lot of healthcare stakeholders starting to publish the data. But we all are very conflicted being. We feel like we need to open, but at the same time, we don't want others to see it. We are making it a little bit difficult to use the data. Another example is, let's say, if you're using a United Healthcare or Aetna or any big payers, how do you know your doctor is in the network? It's called the provider directory, and there are many regulations around payers need to publish provider directory to the consumers. How does this provider directory get published? In PDF. Right? When you publish in PDF, that's right. So you can actually, you publish the data, but downloading it, usually it's a few hundreds of pages that has a bunch of different names on it. Difficult to search, difficult to figure out exactly how to process the data, right? These things happen all the time. And that's why I think this time, things may be different. Now I'm finally bringing up LLMs. I'm seeing a lot of potentials of LLM, not for automating workflow, not for replacing human beings. But I think the biggest advantage of LLMs in my area is I think LLMs can add liquidity to the open data. Right? So let me give you some examples how I use LLMs day to day. This is one example. Actually, I was showing this page to Pinar yesterday. This is a government website by HHS OIG, Office of Inspector General. I've been looking at this website for many years because I had a keen interest in understanding fraud, waste, and abuse in healthcare. OIG does the hard work. They find all these fraudulent perpetrators, and they charge them, and they announce what they have done, how people got affected, exposed, and the monetary implications, and all those detailed information come out, right? That kind of information gets published like a news article every day. For me, it's good if I have time to go to the website every day and collect the knowledge and all those things. Maybe that's good enough. Unfortunately, I don't have that much time. So I was debating, how can I make it more database-fied? How can I use it better? How can I search it better? How can I categorize all these different cases so that I can plot the trend over time, so that I can understand better, so that I can actually use these data to do something else? What I'm actually doing, this has been working well, is I've been scraping the government web pages. And I'm actually asking, I've been using this specific LLM, not for I don't have any relationship with the cloud. But I think a cloud has been particularly working well for me. I send it to Claude, extract the key information from each article. I'm running this script every day. What does it extract? It extracts the subject name, who did it, where are the affected areas, what's the amount that is affected, exposure, what is the sentence, what's the progress, is it charged, is it being in progress, or something like that. All these things get extracted, and I'm putting it into a database, right? By doing that, actually, I can see the patterns a lot easier, where things are happening, and what kind of fraudulent patterns are emerging, and what is the focus of the OIG these days. So I've been actually documenting a lot of data using AI. This is another example. This is different, actually, what they call it as a Medicaid exclusion provider from Nevada. Each state government runs a Medicaid program. When some providers are charged for some crimes they committed while providers had something to do with it, then they put the providers into something called exclusion list. If you are put in exclusion list, you cannot perform Medicaid services, right? Medicaid exclusion list is published in PDF. It's very difficult to find exact information I want. And the funny thing is, this PDF has been bothering me for many years. I don't know why. I think, I don't know if this is recorded. I don't know if this will go to the Nevada government or not, but I think somebody who's publishing this data sheet, I think they are generating manually. What's going on is every month they publish it, the size of table becomes a little bit different. Cell size become a little bit different. Sometimes they change the layout a little bit different. So before LLM, I was trying to parse this PDF. Every month, I need to go fix it. I cannot automate it. I was having too much time. Then there is an LLM that can parse PDF a lot more reliably than me, right? So I'm feeding this PDF to this LLM model called Upstage. It's actually giving me a very nice extracted data without for me to working on these all the small parameters of the table layouts and all those things. Now I can just feed it to LLM, and it's giving me cleaned up table. Now I have the Nevada exclusion list monthly updated in a stable way. This is another example, and I'll be going over a lot of different examples. And please stop me if you actually have any questions. If you think it's kind of silly or it doesn't make sense, please ask me any questions. I'll be going over different examples one by one. How I'm using AI to add liquidity to the open data.
So Yubin, I have one question.
Yeah.
So I'm just thinking about how you operationalize the
Yeah.
LLM, like in the Nevada case, for example.
Yeah.
So you're still using cloud AI,
That's right.
but then you said you use a specific LLM model.
That's right.
So how does it, like, can you maybe walk through, like, how does it work? You wrote a code to basically go to the exclusion list every month, and then.
That's right. So I write a script. Usually, I'm comfortable writing Python script, but to be honest, I think any language, any program language can do something similar to this. I write a Python script, and I schedule the script to run in a fixed sequence. For example, in Nevada case, I run it one time every month, right? So that script will go to the Nevada website, check the file is updated, and if the file is updated, you can check it by looking at the HTML code. Yeah, so you parse the HTML, and you check the file is updated, and you let the program download it. Funny enough, these things, you can also ask LLM to write the script. So in the past, I could do it, and it is my proprietary knowledge to do it. But I think to some degree, LLM is liberating a lot of these things as well, because even if you don't know how to do these things, you can go to their Claude, ChatGPT, and you can start conversation. I have this URL. I want to go scrape the web page. Where should I start? It'll actually give a step-by-step explanation how you can do it, right? And then the file gets downloaded, and it comes to my cloud storage. And then I read the file from my cloud storage, and that gets sent to my choice of LLM. Yeah, I need to have a bit of a trial and error because each LLM has a different strength and weakness. So I have an array of different candidates, and they tried it out, and they pick the best one based on my judgment. Yeah. Then when the data is parsed, then still it needs a bit of work. LLM is not perfect. Again, it hallucinates quite a bit. So you need to do a bit of a check. So you write a bit of a kind of programming check to make sure that the data is correct in the right format. Then you put it into the database. By the way, actually, this morning, I was having an issue with this process, and I was fixing it before you came to my the hotel. Yeah. So this is a little bit different example, and a little bit of side topic, but it's sad to see a lot of meaningful and scientific data are disappearing these days. Actually, I didn't check whether this data is still there or not, but this data, as an example, is called NHANES data. It's a survey data conducted by CDC. It has been running many years. It's running in kind of multiple batches. And they design the survey questions, and they run it. It's about their nutrition and health, and it actually is about almost anything that is about biometric readings, their visits, their diagnosis codes, and all those things. It has a rich information. The downside is each batch has a different focus. Yeah, right? So it's been running maybe kind of more than a decade, and it had many different batches. There are some central theme of this survey. It's about, in the end, nutrition and health. But each year, as we know, the focus of the government, new administrations change. They want to focus on something particular. They want to move away from the different things. Each batch has a different variables, and a lot of times the definition of the variable change, right? What I actually want to do, and what's untapped in a lot of public health data, is weaving out longitudinal records in a consistent way. And not many people cannot do it easily in the past. I'm not saying I can do it perfectly, but for enhanced data, for example, when I run it and they get help from cloud, it was a lot easier to align the variables and how to match up different batches. And I could do it in probably a half a day, and I stitched together multiple batches for now in a few hours. Before LLM, stitching together enhanced data is a big issue. And there have been actually multiple academic papers about how to stitch the data. And if you know about writing that kind of academic paper, you would understand one PhD student would have spent probably 4 semesters stitching data. Now, stitching together data can be a lot easier, and it can be maybe in a few hours. Any questions so far?
Two questions.
Yeah.
The first question is on just the leveraging the LLMs to make the data more liquid.
Mm-hmm.
I think earlier in the presentation, you talked about asymmetry
Yeah.
is almost like a feature
Yeah.
to some degree in healthcare system,
Yeah.
where asymmetry allows some payers, providers, whoever it is, to probably have a financial advantage. Now that you have this model where you could break down the complexity and the unreadability of data into something that's more liquid, do you see them pushing back to say, hey, this wasn't really meant to be liquid. This was meant to be complicated.
Yep.
And now you're making it easy. So that's kind of the first question, like, what's the pushback there?
Yeah.
And then the second question is on your topic of efficiency. I know, like with DeepSeek, right? They were able to build an AI model that's not as big as like Claude or
Yeah.
Gemini or these different things. It was really focused. Could you make an LLM that's healthcare specific and not a general all-purpose LLM?
Yeah. So regarding the first question, so actually to extend my morning story a little bit. So I was fixing that OIG website, but actually I had another issue from FDA website. FDA published this thing called the Orange Book, Purple Book. It's about the devices. And it was causing an error suddenly. And it was running fine. I couldn't download Orange Book. I need to investigate a little bit more. I think it flagged my IP address that there's a fraudulent. So it's kind of interesting. So data is open, but they don't want you to scrape the data. And those things will be always pushed back. I need to figure out in a different way. Because technically those data are meant to be used. And maybe some shared IP I had may have some different activities that can flag FDA to shut it down. But those things happen. Always people who are already in advantage with the information asymmetry, they probably would want to make that, maintain the position. Because as the information flows more freely, that the moat goes away. But I think development LLM, what's exciting about it is actually, in many ways, they cannot block humans to read the data. In the end, that's kind of the minimum requirement of the publishing data. And the LLMs are almost like a human. As long as we can read the data by ourselves from the website, eventually LLM will do the same. So I think whatever kind of people try to block the information, I think a technology advancement will kind of move it away. One the downside is to use the LLM, you need a bit of a capital. So still there is a bit of a cost to ingest the data, but hopefully the cost goes away. Regarding the healthcare specific LLM, I think it's in need. And there are a few healthcare specific LLMs, mostly in the medical side these days, regarding healthcare delivery. LLMs that are being used for transcribing conversations in the office setting, LLMs for predicting some outcomes or admissions and those things. But I think LLMs for all these different data types and knowing the healthcare jargon, I think it'll be very helpful, especially for me. Actually, then I can use those things because healthcare jargon is still very complex, and it can actually be very ambiguous when you have a general LLM to know something when they abbreviate into something different. Yeah. So I'm using LLM as a lot of different ways. And another example is I use LLM as a data commentator. So when you're downloading a data, what do you do for the first place? When I'm looking at the data, when I find a new data set, the first thing I do is to find data dictionary, right? You need to have a data dictionary to understand what the exact column means. I mean, sometimes you can guess based on the column name. A lot of times what you find as a public data set, they have a very weird column names. So a lot of times you cannot quite guess it. And the funny thing is, data dictionary is not commonly available often the time. And even if there is, sometimes data dictionary is not comprehensive and very friendly enough for people like me to understand. What I found by trying it out is actually LLM somehow has a lot of some hidden knowledge, probably kind of somewhere in the web that I couldn't find. They know about some of those data sets. As long as the public data sets has been, probably LLM may have read some papers back in the days that used the data set. LLMs may have known whatever people have done in the past. What I actually, when I tried it out, ask LLM to, can you make new data dictionary? These are the data I have downloaded from this source. I want to use it for this. People have been using this data, blah, blah, blah. And these are the data samples that I can provide. What do you think about this data? Surprisingly, a lot of times it knows what the data is and it can fill it up, the data dictionary. So I've been using LLM to comment and create the data dictionary for the data set I curated. The size of the data is quite big. Actually, I already have curated about the 20 terabytes of the publicly available healthcare data. It has more than 20,000 variables in my repository. That's kind of what I do. I'm a data holder. But all these 20,000 variables, I have ran LLMs to make complete data dictionaries, and they are all nicely described. I have reviewed many of them, and it makes perfect sense. And for those people who actually want to use these kind of data for the first time, I think that kind of explanation will be very valuable. And I'm going a bit more kind of one more step. So what I actually found very interesting and very effective is having the data dictionary sometimes is not just enough. I actually had a lot of difficulties learning from textbook and listening to lecture. My wife and I used to take courses, and I think, I don't know if I have an ADHD or I don't know, I never got diagnosed, but I cannot quite focus on the lecture. A lot of times, the way I learned is by doing homework. I am the type of person who learn by doing it, who learn by seeing the examples. That was kind of best learning for me. And I was thinking, maybe I can do something similar if there are people like me who want to learn by examples. Data dictionary may not be enough. Can I make some examples based on the data and the dictionaries and have tried them out? Actually, LLMs can create very nice, simple examples that run on the real data without error. And for those creating errors, usually I wrote a program to read the error message to feed it back to fix it. And it fixes the error in a couple of tries. And I can actually create nice examples that run on the real data and that they can describe what the examples do. So that in my repository, there are thousands of LLMs generated examples already available. So this is actually showing some of the LLM generated queries. Sometimes it can be very, very sophisticated. I don't write this kind of long SQL queries by myself. And they actually write it perfectly indented, and the perfectly documented code can be generated by LLM. And I think it has been helping me to learn about new data faster.
Yubin, could you give like an example of an example that, like the example that you generate like from one of the data sets?
So the one example, so the government publish a lot of different data, especially regarding the Medicare, because Medicare is fully funded by the federal government. A lot about utilization and the quality metric, and also the provider performance, and also some variables around the provider demographics are available in public. So there was one particular data set that contains, let's say, Medicare eligible doctor, providing Medicare services. It's actually available if you go to data.cms.gov. You can actually see the data right now. The data is pretty big. Doctor and the HCPCS code. It's a procedure code, and how many times the doctor provide per year. How many beneficiaries he provided this specific HCPCS code. What is the charge he requested? What is the payment Medicare did? And all those different variables come up. One example I saw creating on its own is finding the best diabetes treating doctors. How do I know that? To be honest, it's a very delicate question. How do you know actually best diabetes doctors? But what LLM did was pretty interesting. It took some diabetes related procedures, and it provided a high volume they're essentially explaining this doctor provides these services more focused than any other services, must be good at diabetes, treating diabetes. So that it was kind of writing that kind of script. So it was creating how to rank the providers based on the diabetes related treatment, the volume and the patient volume and all those things, rank them, and they're kind of giving the top 10. Yeah. So it can do quite sophisticated things. But I mean, again, we cannot quite completely trust it. In the end, somebody need to review it before actually you're using it. But it's very impressive a lot of times. And this one, probably the last example, I believe. This one is something I've been trying quite a bit. And funny enough, Pinar knows me from my LinkedIn. But a lot of times, my LinkedIn post is with LLM, because I use LLM as my research assistant. I ask because when I was doing a startup, my second startup, a liberal side topic. When you're running a startup, you have a limited budget, and you don't want to spend too much on marketing. CEO or CTO become essentially marketing vehicle. You need to have your own brand. And I wanted to build my own brand. One thing I quickly realized, it's interesting dynamics in LinkedIn is LinkedIn deprioritize self-promotion articles. So I tried a bunch of different things. Whenever I wanna, write something about how good my product is, look at me, I did something great, blah blah blah, self-promotion articles. LinkedIn actually doesn't promote it. I think it's a kind of, to incentivize people to write different things. What actually LinkedIn promotes is an informational article, educational, and that actually articles that get more traction. People, press a, thumbs up button more, a heart button more, something like that. After I figured that out, I started posting a lot about data-related stuff. That's kind of how my data journey started. So when I actually was doing, I needed a bit of a target. So my self-target was, let me produce one LinkedIn article per day. And I've been keeping the promise for about 4 years. I'm discovering some weird patterns in the data. And they are writing about, oh, look at this. Did you know about this? Blah, blah, blah. It's not about me. And I'm trying to kind of have people to look at some anomalies and different patterns in the data. And I've been doing that every day for many years. People ask me how I do it. And they are actually kind of, sometimes people ask me, how many team members do you have? So they are kind of, who do you work for? For me, something like that. I still work by myself, but I work with LLM, and I essentially kind of explore the data with the examples generated by the LLM. They give me a different starting points to look at. With all the data, they spotlight the different patterns, and they actually kind of do different exploration on its own. I look at it and see it, oh, that's interesting, weird. Why is that? A lot of times what I do is I actually add my thoughts and ask back LLM, why is it happening like that? And the LLM provides different explanation. This is one example. So this is actually something called HCPCS code volume. So every quarter, government defines a different set of the procedure code. Because there are tons of different new treatments come out, and they need to pick and choose which one to do it. And sometimes they actually retire some procedure code that is not scientifically valid anymore, or something that is harmful to the patient. Procedure code change over time. One day I was plotting the procedure code volume. What type of procedure codes are being approved or added over time. So that I was plotting it from 2000 to the current, right? And I see a cluster of psychiatry codes in 2012. You see this red mountain. Those are suddenly added, and I was asking question to Claude. Why am I seeing that? And it says a bunch of different things. And I did a bit of research, which I didn't know anything about these, ACA and the Medicare Modernization Act and all those things. When I looked it up, oh, it makes sense. Those are the days actually, psychiatry treatments had some reform or kind of having some parity with the different codes. A lot of new codes were added around that time. And I learned new things by spotting some pattern, asking that question to Claude, and verifying it by myself. This is another pattern I did it. This is a Medicaid drug utilization data, also available publicly. You can actually get the data from the data.medicaid.gov. So there is a website called the data.medicaid.gov, and you can actually download state-level drug utilization. And I was plotting it, and one particular drug I was plotting it, it's fairly famous drug called Oxycodone. And I was plotting it, and this is a pattern, you see. The volume in the Medicaid over time. And because I didn't quite live this period, I was still in Korea and I was studying, I think around 2000, I was already still a college student and then not in the US. I didn't know exactly what happened. I see some peak around the early 2000s, suddenly going down and going up again and stabilizing it. I was asking the question to Claude, and it was giving an explanation about how the patterns match up with what was happening in the world. Is it true? I don't know, but it gives some clues to start. Yeah. Again, this is an image I generated with the LLM. So I think, again, healthcare data has been open many years. And I think it has a lot of economic values and the research values. But unfortunately, the data is not quite liquid enough. Data is difficult to use. At the same time, the industry is really complex to learn. And I think LLM can remove the barrier of that learning or potentially make the speed up the learning curve. At the same time, adding a lot of liquidity to this open data. And then we can mix all this data and boil a nice data soup to do different things. And they are going against my LinkedIn recommendation framework. So I may do a bit of a self-promotion about this. So this is what I've been doing. So a lot of things I talked about is what I'm doing these days. This is essentially a platform. I've been maintaining it, community. I've been curating a lot of these government data sets one by one. And as I said, the volume of the data is about 20 terabytes at the moment, having more than 20,000 variables. And I think actually I am just scratching the surface. There are a lot of data. If you actually think of using LLMs to parse the web pages, parse the free text data, parse all the PDF knowledge, I think the volume of data will grow and we can stitch them together. So what, right? So what can you do about it after we, all this data, right? So there are a few things I have been doing in the past. Using the open data, in many ways, I wanna make a positive impact to the society. I wanna spot something that is not right, and I wanna fix it, right? So one day, actually, I was a part of this, a program called, Accountable Care Organization. So the Medicare runs this thing called the ACO, and there are a few different ACO programs, and I was involved in a program called ACO Reach. It's an experimental program, it's a pilot program, they say. They try different government agendas, mix it together to see how things will happen. The focus back in the days in 2022 was health equity. So they proposed, can we provide some incentive for the providers that are serving, the underserved population? The intent is very good. I think to think of it, I don't know why government didn't do it before. But the implementation is a challenge. How would you define underserved communities, right? So the government announced that they'll be using something called ADI. So it's Area Deprivation Index. And I was actually running an ACO Reach program in LA area. And what I found out was when you overlay ADI in LA, every area in LA is actually very, very kind of affluent. But have you been to LA? LA is all over. It's really ghetto to the really high. All these kind of crazy rich people as well. But the spectrum is really diverse in LA. But it was not capturing much. And I was investigating a little bit further. Then they actually later it revealed. Now actually it's kind of verified in the academic community as well. ADI is heavily correlated with the housing price. Yeah. So the LA, if you go to LA, any area, like some broken down house can cost millions of dollars. And when you actually use the national housing price as a index to assess the health equity, you cannot quite deserve the New York, LA, San Francisco, and those areas. Some parts of the areas in the city can be very, very underserved, and it was not capturing it. So we wrote the blog by combining all these open data and providing the evidence. And the CMS, after 1 year of trying it, they changed the rule to do different implementation. I've been mostly publishing in computer science industry, and I have stopped publishing it after I graduated. But since actually I was doing some work in the healthcare industry, here and there I get involved in publishing papers, not in computer science, but this one is actually published in the I think a health service research or something. Yeah, something like that. So I was doing research around the Medicare Advantage. And I have interacted with a lot of Medicare Advantage executives. And a lot of times, I ask questions. You guys are so centered around the urban areas. Why don't you venture out to rural areas? Because Medicare Advantage industries can be very, very competitive. It's cutthroat sometimes, especially cities like LA. It's like it's like a mafia war. It's very cutthroat industry, and I was kind of jokingly say, there are all these areas that actually has not much of a Medicare Advantage options. Why don't you go venture out? And I was always curious. And in many ways, they always say, oh, it's not a good market. I don't know how to make money there and all those things. And I think in many ways, it's multiple kind of reasons. But I was investigating it. Why adoption of the Medicare Advantage in rural area is so low. And one thing I found out is using Medicare survey data. And found out that actually there is the financial co-pays, co-insurance, those options actually are not as good as the urban area. So it's a chicken and egg problem. So I think probably, when Medicare Advantage kind of reach out to the rural areas, because they expect they don't make a lot of money, I think they set the high bar on the copay and the co-insurance. That also kind of reflect the low adoption of Medicare Advantage. And maybe it's a kind of downward cycle. But what we found is using the open data is actually copay and co-insurance, the financial burden is actually a lot higher in rural areas. And there are a lot of other research coming out from the data I curated. Actually, there are many people who are using the data I studied curated. And there are many different research coming out. Not just the research, I think there are a lot of business opportunities out there as well. So people are using, and hope I'm contributing in a positive way to add the liquidity to the open data. So it's almost end. So am I in a good, yeah? So this is called a data network effect. It's I adopted this image from the big venture fund called NFX. What they say is you need to have this kind of loop to create a positive change and sustainable change. Having data, find insights, make some actions, and get back to the users. Users will generate more data, and will bring them more insights, and then make it better and better. That's what actually what people are discussing these days quite a bit. We have an analogy in healthcare, something called the learning healthcare system. It's actually not a new idea. It's been debated for a long time. People want to move to this direction. There is this slide is coming from the University of Minnesota, so the medical school. So the learning healthcare system is a concept that constantly evolving based on the data, collecting the data, and analyzing the data. And the two provide better quality care to the patients. So using the open data and potentially mixing with some of the enterprise proprietary data, as we remove the barrier, as we add liquidity, I think there are a lot of potentials to make positive changes in the healthcare. So thank you. Thank you for putting up with a bit of boring talk, but thanks a lot. Any questions? Yeah.
Yes, thank you very much, and congratulations on the exceptional work. Truly, truly exceptional. Now, I'm putting on my business hat. How do you monetize this, or is that not an objective? You know, between these large language models, how are they profitable in what they're doing? And then you, as someone who's been able to uncover the rich data, is there an opportunity to monetize that?
So the very good question, and I actually get asked a lot by venture capitalists all the time. When I started Mimi Labs, actually my objective was one thing. Let's put this work in a very long-term gratification horizon. A lot of times we make business that can reward in a very short term. And in the current environment, if I were to do that, I wouldn't start this kind of project. I would parse the data, and I probably need to sell the data with a reasonable market price, which can make a good business. But when I was looking at it, if everybody is doing it that way, it's not solving anything. Somebody needs to flatten out a little bit so that people can easily access data. Then we can think of the next level. Yeah. So my objective for the Mimi Labs, it was pretty simple. And sometimes actually VCs do not like it. My objective was, my goal is not to lose money. So I think I'm pretty comfortable Mimi Labs is heading that way. I think we are collecting a bit of a small membership fee to access the Mimi Labs, and it's covering the most of the computation power. So the Mimi Labs is going that way. But at the same time, I also want to make money. I'm not a philanthropist. That's why I'm running a different company called Falcon Health. That's a bit more business. And I think using a lot of data from Mimi Labs curated, but at the same time, we are using a lot of other proprietary data. That one, actually, we are providing different value. It works in a different value chain. Yeah. So whether data is being cleaned or not. So I did a minimal cleaning. So and here is the reason why. I think data cleaning depends on use of the data. In my experience, depending on how you want to use the data, depending on the application of the data, a lot of times the cleaning method change. Aggregation pipeline change, and some of the filtering, removing logics can change. What I have done was something a little bit simpler. One thing I did was, all this data coming in a flat file, I make all the data map into a right data type. Date as date, character as character, number as number. Those things are all done. And a lot of these data are in an archive format. So I never deleted any data. So it keeps appending it with the new data. So I run this data pipeline every day. It checks all the web pages. Some web pages I do it monthly, quarterly, yearly, but some pages I do it every day. And collect the data and appending it in a way that people can use it however they want. In the community, people write their own cleaning processes. That's a bit of a barrier at the moment. I hope to achieve that the things can be a lot easier, but they're not at the moment yet. Yeah.
So Mimi Labs, our students are basically using it for the first time. Our interdisciplinary health data competition. Yubin has, allowed access to our University of Minnesota students part of the competition in Mimi Labs environment. And I was like, we will see how this goes because it's an interesting environment where the users are in the environment. And we said, let's make it an option, Yubin, to actually download the data too. But I was just really encouraged to see like 50% of the teams chose to stay in the environment because it was easier for them to kind of work rather than just downloading the traditional way we do it in academics, right? You download and you analyze on your computer. And I think the other very interesting thing about it is because one of your examples was documenting, like creating data dictionaries, right? And so because he has done that, so you can actually like ask within the Mimi Labs, correct me if I'm wrong, but within the Mimi Labs environment, like I want to use this kind of data, where can I find it? Like, so these AI-powered chatbots are there for students to kind of search and say, oh, you could probably find it in this data set and look at these variables. And so it's kind of really expanding, I think, the capability of like the way we do. So I have one question. So like, at the university, of course, we care a lot about training our students, the next generation of, in my case, more like the healthcare professionals on the business side or public health, right? And so, and oftentimes when you're training a student who wants to go in healthcare, we focus more on the institutions and the regulatory and the markets and things like that. But we also want our students to know about healthcare data. We don't want them necessarily, or we don't ask them necessarily to, or focus on training them to be like the healthcare data experts, but we want to be able to have them go into their next organization and talk with the person who is working with the healthcare data. So, we've been doing it sort of more traditionally. We have classes in sometimes like demographic health data, like the NHANES and MEPS and NIH. And then we also have classes that maybe train them on like how to use a healthcare claims data, and download, and how do you identify an inpatient hospitalization? How do you identify? So given like everything you described and now powered now with LLMs, like, do you have any suggestions on like, how would you envision, let's say, let me be more specific, how would you envision an undergraduate level data in like healthcare data analytics course? Students have taken some stats, they have maybe done a little bit of Python coding, like, and they have learned about sort of the institutions, what is Medicare, what is, commercial insurance, or, what would be your suggestions on what we should teach them?
It's a very deep question. And by the way, my wife is also a professor at Emory, and she teaches undergrad and grad, and here and there. We also discuss that topic quite a bit. What should I teach to the students? Not just the healthcare data and analytics, but in general. I think LLM is, as you use it, you get amazed, and you also sometimes get depressed. What should I do with this? But there is one saying that I really like. There's this guy called Evan Benedict. He's a very famous VC/analyst. He published a lot of insightful presentation. People read quite a bit, Evan Benedict. Last year, he actually put out the presentation saying that LLM is an infinite intern. So I think it will stay like that for many years. I don't think actually, in many ways, when I'm using LLM, it feels like I am interacting with the interns. LLM is never perfect, and probably it's not designed to be perfect. To some degree, it's mimicking human quite a bit. So in many ways, if you know the subject, the more you know the subject, you spot more mistakes by LLMs. To some degree, we need to go there and fix it. When I'm working with the team, big team members, people write the code and script and all those things, I need to be there to see if they did the right job or not. If you're running a restaurant, owner needs to be there to see all the servers are doing the proper work. To some degree, I think oversight work will be always on humans. And to do the right oversight, I think we need to know the details to some degree. So when I think about what should we teach, to some degree, I don't think the content of teaching may not change much. In many ways, we still need to learn how to program. We still need to learn how to process the data and all those things to spot the mistake by the LLMs. But I think what need to change is probably we need to change the speed of learning. I think there are too many data sets or too much information being generated to keep up with what's going on. I think most likely what needs to be changed is not the content itself, but we may need to think about how can we accelerate the learning. I don't know if that's the right answer.
Okay, well, I think we have a lunch reception upstairs. Well, thank you so much for coming, and thank you, Yubin, for coming. Really interesting talk. And just so many different examples I did not even think for accessible to us. And we would all love you to join our data science initiative events as well as BAC events on our end. We have a really well, if you want to come to the finals to see the top 4 teams, it's today at 4 p.m. at the Carlson School. Anna, do you know the room? Oh, Hanson Hall 1107. We would love to see you there, and students would like audience too. The other event that we have upcoming that we're so excited about is on April 9, our Convene conference, the 7th annual Convene conference that we are hosting. And this time the theme is responsible AI, high impact, low risk healthcare. And we have announcements outside if you want to get a QR code, and please come and join us. And it will be a really, really amazing lineup of speakers as well. And I don't know, Haley, from the DSI team, if there's anything upcoming that you wanted to highlight or... Another plugin for our other University of Minnesota colleagues and the Institute for Engineering and Medicine. It's not AI, but they have this amazing conference called Design of Medical Devices Conference later in April. So if you just kind of Google Design of Medical Conference, it's run through the Bakken Medical Devices Center as well. And they have a lot, they'll have, I'm sure, a component of their program is going to be devices and AI and data. So I think you would be interested. Thank you. Well, thank you so much.
Thank you so much.